there are so many important energy resources on the earth that we rely on every day. And the biggest one, of course, is the sun that is providing all the energy that we need on the earth. And then all these other processes are linked to that. So, one important fuel that we use, and a fuel is something that produces energy for us, we have biomass fuels and biofuels. So, biomass fuels are things that we directly burn in order to use the heat in some kind of way, and use that energy transfer to help us. So, of course, examples of biofuel, things that we burn, would be here in the picture wood. Another one you wouldn't expect it, but it's also in the picture, is fecal material. So if you've ever heard about cow pies, like lighting that on fire, it's full of hydrocarbons and it'll burn really well. Additionally, there's field crop leftovers that get burned, and lots of other things. But basically, burning these things does give off CO2. The carbon comes off and combines with oxygen to make CO2. And CO2 isn't great for our atmosphere right now in large quantities. So, it's always striking a balance on getting that so that we're not putting too much of that into our air. So one of the things that is also a biofuel, but you maybe haven't heard of it, is peat. Peat is actually this chunk of like root debris that are compressed in kind of boggy water so it doesn't decompose very well. And eventually, that dead and decaying plant material is so compressed that it could actually be burned really efficiently for a fuel. So you can see they've cut it out here and they're drying it, and then they can use that peat. This doesn't have very much carbon in it, like compared to coal, there's not very much carbon in this at all. But it's kind of one of those primer things that if we left this for a really long time, millions of years, it would eventually compress and make coal. So, but you can burn it. Another type that we're going to talk about is fossil fuels. So, fossil fuels are dead organisms that have decomposed, and it's been compressed over long periods of like geologic time, and have made these cool products that we can extract in different ways and get out. Some of them are coal, petroleum, and natural gas. And then, of course, there is like oil shale, which we will talk about. So we will talk about those. Um, where does coal even come from to begin with? Well, originally, energy from the sun came down, it grows the plants, and those plants have debris and roots that accumulate to form peat, like we talked about right here. And then that peat gets compressed over time, um, and it starts to make coal. So, in a sense, even that peat and the coal came from the sun. Here is a cool chart, or a picture, I guess, that is showing some of these processes. This would be the peat. It doesn't have as much carbon in it. And then after that, after it's compressed for a long while, the peat will actually start to compress more into this rock called lignite. And lignite has more carbon than peat. But then the next version of it getting compressed even more would be bituminous coal. And this coal has been compressed even more until it's been compressed to something as nice as this, which is anthracite. So going from least to most full of carbon, you're going to have the peat, then the lignite, then the bituminous coal, and then the anthracite. So oil shale is another thing that is very, and this is a picture just showing how these different things can get trapped underneath the earth. Okay, so you maybe have a water line, and of course oil floats on top of water, and of course air will go on top, excuse me, as a natural gas, and we can tap into that. Oil shale is something that the United States is extremely rich in, and I think you're going to be hearing more and more about this. We have more coal tied up in oil shale, which is harder to extract, but they're getting more efficient at it. But we have more than Saudi Arabia of this. So we're very rich in this product, and as the United States gets better and better at mining it, I'm sure you'll hear more about that in the future. So something I want to mention before I leave this is that anthracite specifically is found deeper than other things like lignite up here or bituminous coal, um, because it needs a lot of heat and pressure to form. So down deep, it's going to be exposed to a lot of heat and pressure. So one thing that's gotten really popular in California is solar energy, and there's a few different ways that we get solar energy in our homes and cars. One way would be passively. Okay, this is like you're sitting near a sunny window and it's getting hotter there. So you didn't try to make this happen. It just happened. Sitting in a hot car or something like that. It's just a heat because you're in the sun. The other way you can get heating is through active solar heating. So these are some solar panels on the side of a house where the individual panels are storing the extra heat, and it's getting stored directly into the house. People will also use a similar type of active solar energy that you'll see commonly in Southern California, where people have something like this. This is not a standard solar panel. I want to point that out. So what they'll do is they'll have like some black tubes like this, and they actually pump pool water up to their roof, and it goes through all these different like lines back and forth, getting hotter and hotter till it's basically almost boiling, and then it gets pumped to a line back into the pool. So it's constantly just, you're running the pump, but you're not paying a boiler to turn on. You're just using the sun's energy to heat up the pool water. So another thing that's become really popular is to use traditional solar panels, and they don't have a picture of that here, but they almost look like this. You've seen them before on top of roofs and things. And regular solar panels are called photovoltaic cells, and they've gotten there. They're extremely efficient. They use two layers of silicone to trap that light energy, and then that light energy can be converted and stored either with batteries at your home, or if you're hooked up to the electric company still, then you'll run your meter backwards when you're making extra light during the day and extra energy, and then during the night when you're off solar, they will pump the electricity back to you and usually sell it for many, many, many times more than what you sold it to them for earlier in the day. But that's how that works for not having your own batteries. I do that every single day in my house. Okay, so another way that we get energy is through water. So this is using like hydroelectric power, which is basically falling water through like dams that produce energy. Another way is through nuclear fission. This is splitting different atoms, and we use the heat that comes off of that splitting process to just basically heat some water. And so we'll pump water in from a body of water like a lake or the ocean. We pump water in, we use the nuclear reactor to split the atom that heats the water. The energy is then used to heat the water, and that plain water that's not affected by this, it just was heated up, will spin a turbine. That's something that generates power, um, And then the hot water that came off of that will just pump it right back into the lake or to the ocean. This is actually an extremely efficient process. It's actually nuclear energy has a really bad rap, but it's actually a very clean form of energy. But when this was first starting out, there was a number of nuclear plants that had major meltdowns and scared the public to this source of energy. So currently, you don't hear about many of these being built, but it is a very efficient ways. They're still being used. I'm not too fearful of this because I think that they've done a very good job with this for the last like 30 years, but it's some one way that we are getting power. The next is geothermal energy, which is just using the energy from different steam vents that we have naturally occurring inside the earth. And this comes up, and same thing, will spin different like turbines and will create energy that can be used later.